So, good afternoon. Let's uh, let's take a look at our next lesson here. All right. So we are now moving on to ratios and proportions. We're still solving equations, so we're going to look at that in terms of how do we use ratio and proportions and how do those fit in. So I think this lesson to me is super useful. I actually use a lot of the skills from this lesson in regular problem solving and daily life things when I'm doing home improvement projects or anything like that where you got to figure things out or do conversions and things like that. These are really useful skills. So I hope that you enjoy this. And hopefully see the use in it. And there isn't a parts 1 and 2. I just never got rid of that from the last slide. So let's get started. Okay, so the first thing we're going to do is we're going to look at basic regular equivalencies. So we've got two fractions. We've got 2/3 and 16/24, and we want to see if they are equivalent ratios. And equivalent means that basically they're the same number, right? They're just two different ways of writing numbers. So a real common equivalency that a lot of you might know is if you have 1/2 and 2/4, right? You would say those are equivalent fractions because you can take the 2/4 and you can divide both sides by 2 and it will get you down to 1/2. And so when you're doing that with some of these other numbers, it's the exact same process. So usually I think the easiest way to do this is just take your 2/3 and then put your 16/24 over here, and then just start with the top and say to yourself, okay, what do I got to do for 2 to become 16? Well, I would have to multiply it by 8, right? Now, if these are equivalent, that means exactly what you did here is what we should have to do down here in order for this number to come about. And in this case, it does work out. 3 times 8 is 24. So these are equivalent ratios. They're two ways of writing it the same way. Okay, and this has a lot to do. It's kind of like almost reverse simplifying fractions. So let's take a look at a few examples here. So this top one here, we got 6/10 and we have 2/5. So let's put them across from each other and see what we got to do to go from one to the other. Well, to get from 6 to 2, I divide 3. And if I divide 3, if I take 10 and I divide it by 3, I don't get 5. You get like 3.333. You get 3.3 repeating, right? So this is not an equivalent ratio, okay? Because you don't get the same thing. Because in order for this to be true, you would have to actually divide this by 2. And you want that should be the same number. It should be 3/3 or it should be 2/2, but that's not how it works out. So not equivalent. All right, let's try another one. So we got 1/6 and 5/30. All right. So in order to get from 1 to 5, we multiply by 5. In order to get from 6 to 30, we multiply by 5. You're doing the same thing on the top and the bottom. Therefore, yes, it is equivalent. All right. So on these next 3, if you want to stop the video and try these on your own, please feel free to do that. Okay, number 1, 3/7, 9/14. Okay, well, to get from 3 to 9, you have to multiply by 3. So in order for this to be equivalent, I have to multiply by 3 on the bottom. But I'm not, am I? No, I'm not. I'm multiplying by 2. And because I'm multiplying by 2, you do not have that fraction of the same number over itself, right? It should be 3/3 or 2/2, but it's not an equivalent fraction. Basically what you're doing when you're expanding these or simplifying them is you're multiplying by 1. You're just multiplying by 1 in a number of different creative ways. Okay, let's look at this next one. We got 7/8 and 42/48. Well, to get from 7 to 42, you got to multiply by 6. And then if I multiply by 6, I should get the bottom number. And in this case, I do. So this works out. So this would be a yes. Sorry, I didn't write the answer down on this one. No, yes. And then on this one, right, we got 2.8. It's the same thing, right? So to get from 2.8 to 1.4, I divide by 2, all right? Just kind of move the decimal for both of them, and 28 and 14 makes a little more sense. So that means that I should have to divide by 2 to get the next number. If I do that, I get 2.2, but that's not the number. The number is 2.1. So this does not work. You're not dividing by 2 to get 2.1. You're dividing by, 2 point something else, right? So this is not an equivalent ratio. And that is basically the way you can do these. Now, there's this thing that the book talks about next called the means extreme property of proportion. This is a big, you can feel free to read this and all that, but this is a big way of saying cross products work. Now, in order for a cross product to work, to check whether or not something's proportional, it has to be going across an equal sign. So you need something that's going to be like, 2/3 equals, right? And then we'd say 6/9. And then if you do cross products, you basically, and I've heard it incorrectly called butterfly. It's not called butterfly, it's called cross products. All right. You take that and you go 3 times 6. So that's one side. And it doesn't matter what order you do it in. And then here you got 2 times 9 on the other side. And then if this is an equivalent fraction, this should work out if these are equivalent ratios. So 3 times 6 is 18. 2 times 9 is 18. And this one you get an equality. So this definitely works out. So yeah, let's do some of these. All right, use cross products to determine whether each pair of ratios forms a proportion. So we have 2 and 3.5 on one side, and then we'll set it equal to 8/14. All right, so let's do this. All right, so we'll go 2 times 14 is equal to, and then 8 times 3.5. All right, well, let's figure out 2 times 14 is 28. And then 8 times 3.5, well, 8 times 3 is 24. 8 times 4 is 32. And 0.5 would be halfway between those, and that is 28. So, yeah, yes, they are proportional, all right, because it worked out. And when you're doing these, I want you to show your work, and I want you to do exactly what I'm doing. All right, let's look at B. So we're going to take that, right? We're going to set it up as if they are 2 equivalent ratios. So we have 2 times 2.0 times 0.3 should be equal to 1.5 times 0.5. All right. So 1.5 times 0.5 is going to give us 0.75. I know that because 5 times 15 is 75. And then you move your decimal place 2 spaces. And we're going to do the same thing here. So 2.0 times 0.3 is going to give me, let's see. Well, 20 times 3 is 60. And if we move it 2 spaces, you get 0.6, right? So we have 60, we have 6/10 or 60 hundredths, and we have 75 hundredths. And if you look at this, these are not equal to each other. Oops, that's not what I meant to do. So if they're not equal, the not equal sign is when you put a line through the equal like that. So these are not equal to each other. So therefore, this would be a big no. It does not form a proportion. All right, you try these and come back and check your work. Okay, so set them up as if they are equivalent, and then do your cross products. So 0.2 times 0.9 is going to give me 0.18. And then over here, we have 1 times 1.8, and that gives me 1.8. And so while they look really close to each other, they are not the same. So these are not equivalent. So that would be a no. Now, what's tricky about this is you got to make sure that you kind of understand this. If you think about it, if you're taking 2/10 of 0.9, right? Well, 1/10 of it would be if you moved it over to 0.09. So 2 of those is how you get your 0.018. So you know that it's going to be smaller than 0.9, right? Because it's 2/10 of it. Well, you're taking a whole 1.8. So right away when you see that problem, you should have red flags going off. All right, so 1536 should equal 3540 seconds. All right, and so we've got a nice big ugly multiplication problem here that I am completely not ready for. So we have 36 times 35. And I'm looking at this, and I don't know about you, but 15 is a little less than half of 36, right? And I'm saying this all before I've looked at my calculator, and I don't remember this one at all, all right? But 35 is more than half of 42. So I don't think these are going to be equivalent, okay? I really don't. So let's try this. So 15 times 42, and then you do the work, you know, to check your assumptions, see if you're right. And then 36 times 35 gives me 1,260. So yeah, they're like not even close to each other, right? So no way, they are not equivalent. And hopefully you start developing enough number sense where you can kind of see some of these things and figure that out on your own. All right, now, how can I use this to actually be useful? Well, you can use proportions in the cross product to solve equations. And it's really useful when it involves fractions. And that's why what I was saying earlier, if you don't like fractions, you're going to like this lesson because it's a great way to get rid of them. So I'll just show you, I'm going to dive right in, show you how this works. So we're going to treat this exactly like the last set of problems we did. We're going to do cross products. The only difference is we have variables now. So we got 10 times 3 on one side. On the other side, you have 5x because 5 times x is just 5x. So you have 5x equals 30. And then you just solve this like a one-step equation. Divide both sides by 5. And then you get x is equal to 6. And then put it in and see if it works. Well, 6/10 is definitely 3/5 because divide both by 2 and it works out. Okay, so x equals 6 is brilliant. All right, let's try another one. So on this one, it's going to be the same kind of thing, all right? The only difference is you're going to have to do a little distributive property with this one, and that's okay. So let's do this first because that's easy. So 14 times 2. And then over here, you're going to have 7 times, and then treat this like it's in parentheses like that. So that's where the distributive property comes in. Okay, so multiply 7 times all those things there. So you get 7x minus 14. And then over here, 14 times 2 is 28. And so now we're just going to add 14 to both sides. Get 42 is equal to 7x. Divide both sides by 7. And you get x is equal to 6. Okay? And if I put that in the equation up here, you get 6 minus 2, which is 4. So is 4/14 equal to 2/7? Yeah, it is, because you can divide both by 2, right? Okay. Now we're going to look at a couple examples of word problems here. And in doing so, you'll get a little more practice with solving these types of things. It takes 7 minutes for Isabella to walk around the gym track twice. So what we're going to do is we're saying 7 minutes, right? And I'm going to do this with units, but normally you don't need the units. 7 minutes relates to 2 laps, all right? And that's around the gym track twice. At this rate, how many times can she walk around the track in a half hour? Well, a half hour is 30 minutes. And then they're saying, how many laps? Well, we don't know how many laps. So we're going to call that x. And that's what we want to find out. So if you set this up like that, then you basically have 7/2 is equal to 30 over x. And then just do your cross products. Well, 7 times x is 7x. And then 2 times 30 gives me 60. So you have 7x equals 60. You're going to divide them both by 7. And you're going to get x is equal to 8.6 something, 8.7. Let's figure it out. 8.57. All right. So we'll just say how many times, and we'll just say 8.6 times. All right, because 0.57 doesn't really mean anything in terms of a lap. All right, 6/10, yeah, you can kind of figure that out. But if you're getting super picky, it's really doesn't make sense. It's not called for. So you can use these to set up like little conversion problems and things like that too, which is super cool. And it is really useful. You can actually use this when you're like trying to figure out like, well, if, you know, if 2 boxes of macaroni is blah, 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 how much is 5? You know, you can use it to check to see if sale prices are actually sale prices, even though they say they are. You can use it for quite a few different things. All right, you can also use it for scaling things, all right? So if you think about maps and models and things like that, where you have representations of much larger things, but you make them really small so that you can see them. If it's to scale, that means if you blow it up, it's going to actually have the same proportions as the original thing. All right, so on a model airplane, the scale is 5 centimeters, so 5 centimeters compares to 2 meters, all right? If the model's wingspan, so we're on the model now, and we're talking about the model to the real thing, all right? So if the model's wingspan is 28.5 centimeters, what's the actual wingspan? So that would be x, and it's going to be in meters. And so we're just going to do our multiplication. So you're going to get 5x. You can just drop your units once you do this part. All right, and then you have 28.5 times 2. Well, 28 times 2 is 56, and then 0.5 times 2 is 1, so 57. All right, so we're going to divide both sides by 5. And I'm just going to show that I did that over off to the side so you guys understand what I did. Okay, that's how you got 57. Divide both sides by 5, and then you are going to get 11.4. And I know that because 11 goes into 55 5 times, right? So 55 divided by 5 is 11. And then if you have 2 more, that's 2/5, and 2/5 is 4/10. So x equals 11.4 meters, and that is the wingspan of the actual thing. And that may not sound like a lot, but remember, 1 meter is a little longer than a yardstick. So you're talking about a little more than 3 feet. So the actual wingspan of this is probably getting close, like 35 feet, somewhere around there. So that's pretty wide, right? That's about as wide as the long side of my classroom, right? I think that's 40 feet, so it's just 5 feet shorter than that. Okay, so I hope this helps you. I would suggest just making sure you're being really methodical with how you're setting these up, and yeah, and then good luck with these. I hope you have fun with them.